Hey, cosmic adventurers, welcome to Singularity, the channel where we unravel the wildest mysteries of the universe. Today, we're diving into something epic, the death of our sun. That massive glowing fireball that lights up our days? Picture this, a swollen red giant, a scorched Earth, and a future where humanity might need to hitch a ride to the stars. What happens when it runs out of fuel? And what's Earth's fate? Grab a snack, settle in, and let's blast off with Singularity to find out. Alright, let's start with what keeps the sun shining like a galactic rock star: nuclear fusion. This core is crazy hot, about 15 million degrees Celsius, hot enough to melt anything you can imagine, and super squished, with pressure like a gazillion cars piled on your fingertip. Here's how it works. The sun takes hydrogen atoms and smashes them together to make helium. But with a twist, when those hydrogen atoms fuse, they release a burst of energy. Why? A teensy bit of their stuff turns into pure power. Now let's talk about the sun's favorite snack, hydrogen. The sun is absolutely stuffed with it. About 73.5% of its mass is hydrogen, which is like 1.4 octillion tons. Imagine a number so big it'd make your calculator cry. Every second, the sun gobbles up 600 million tons of hydrogen, turning it into helium and spitting out energy like a cosmic dragon. This hydrogen feast is why the sun's been shining for 4.6 billion years. But here's the deal. Even with all that hydrogen, the sun's not eating forever. It's got maybe 5 billion more years of hydrogen left in its core. Picture this. It's 5 billion years from now, and the sun's core is low on hydrogen. It's like running out of gas in the middle of a road trip. The core's been fusing hydrogen into helium for ages, but now it's mostly helium, and fusion slows down. Without enough fusion, the core can't push back against the sun's gravity, which is like a giant bear hug squeezing inward. So the core starts to shrink, getting denser and hotter. But here's where it gets spicy. As the core shrinks, the layers just outside it heat up enough to start fusing hydrogen themselves. It's like the sun saying, "No hydrogen in the core? Fine, I'll fuse it somewhere else." This new hydrogen-burning shell around the core burns hotter and faster, pumping out way more energy than before. All that extra energy makes the sun puff up like a marshmallow in a microwave. Welcome to the red giant phase, where the sun's about to become a cosmic bully. As a red giant, the sun's gonna get huge. Right now, it's about 1.4 million kilometers across, but in this phase, it could swell to 200 times its current size, big enough to swallow entire planets. Its surface will cool a bit, turning red like a glowing ember. But don't be fooled, it's still a beast. In about 7 billion years, the sun might stretch so far it reaches Earth's orbit, 150 million kilometers away, gobbling up Mercury, Venus, and maybe even us. What's that mean for Earth? Trouble? Big time. Even if the sun doesn't swallow Earth whole, its heat will turn our planet into a cosmic barbecue. The sun's gonna get brighter way before it hits red giant mode. In just 1 billion years, it'll be 10% brighter, enough to boil Earth's oceans. Picture Earth as a steamy sauna with no off switch. By the red giant phase, Earth could be a molten lava ball, or worse, just dust inside the sun's fiery belly. The oceans will start evaporating, turning Earth into a foggy, boiling nightmare. Temperatures will climb, making it impossible for plants, animals, or us to survive. The atmosphere might even get peeled away, leaving Earth naked and scorched, like a forgotten cookie in the oven. Oh, and as the sun bloats, it'll start shedding its outer layers like a snake losing its skin. This makes it lose some of its grip, so Earth's orbit might drift outward a bit. But don't get your hopes up. Earth's still gonna be a crispy mess, whether it's swallowed or just baked to a crisp. Back to the sun's drama. After its red giant phase, the sun's core is mostly helium, with some hydrogen still burning in a shell around it. But gravity's not done yet. It keeps squeezing the core tighter, heating it up until, boom, the core starts fusing helium into heavier stuff like carbon and oxygen. This helium fusion is like a second wind, but it doesn't last long, maybe a few million years. Eventually, the sun can't keep it together. It starts coughing off its outer layers into space, creating a dazzling cloud called a planetary nebula. Think of it as the sun's glittery goodbye card. What's left? A tiny, super dense core called a white dwarf, about the size of Earth but with half the sun's original mass. The sun used to weigh 330,000 Earths, but now it's down to maybe 165,000 Earths worth. That's like going from a heavyweight champ to a featherweight. So, the sun's now a white dwarf, a hot Earth-sized marble floating in space. At first it's blazing white, but it's got no fuel to make new energy, so it just cools off, slowly, like a cup of coffee left out for billions of years. Over trillions of years, way longer than the universe has been around, it'll fade into a cold, dark lump called a black dwarf. By then, the solar system's a ghost town. Any planets left, like maybe Jupiter or Saturn, are frozen rocks orbiting a dim speck. The planetary nebula's long gone, its sparkles scattered across the galaxy. Okay, let's talk about us, humanity. The sun's slow roast will make our planet unlivable, so we'll need to bounce to another star system. Imagine packing up and moving to a new cosmic neighborhood with a younger, friendlier star. Maybe we'd aim for Proxima Centauri, 4.2 light-years away, or another sun-like star with cozy planets. But it's not like hopping on a bus. Space is huge, and even super-fast ships might take thousands of years to get there. We'd need giant colony ships, maybe even space cities, or figure out how to build homes on alien worlds. And we'd have to start planning early because a billion years sounds long, but the clock's ticking. Phew, what a cosmic roller coaster. From the sun's fusion fireworks to its white dwarf wind-down, it's a story that shows how even stars have a life cycle, and ours is tied to it. Here at Singularity, we love exploring these mind-bending ideas, and I hope you're as pumped as I am. Could we really escape to the stars one day? What do you think? And hey, what's next for Singularity? Wormholes? Alien planets? Drop your ideas in the comments. I'm dying to hear them. If this blew your mind, give it a big thumbs up to keep the cosmic love flowing, and hit that subscribe button to join our Singularity crew for more universe-shaking adventures. Thanks for hanging out, explorers. Let's meet back here for the next big question.